Okay, for this video, what I'm going to try to do is, again, show another quadratic in standard form, only this one cannot be factored. So if you take a look at this problem, our C is 3, and it's a positive 3. Okay, so if I were starting to factor this, I'd think about factors for 3 that can be combined to get 2, and I would think to myself, all right, well, positive 3 and negative 1. Well, in this case, like I said, our C is positive, which means our signs for our factors will be the same thing as B, which is also positive. Okay, so I can't combine positive 3 and positive 1 to get positive 2. So factoring is no good for us. Factoring does not help. So what I'll try to use is the quadratic formula to try to find the x-intercepts. Okay. What we can do is remember the formula negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, like I said, inside the square root is usually where people mess up, so we're going to make sure we do that very, very carefully. Alright, and what we have is negative b is 2 plus or minus the square root of 2 squared minus 4 times 1, which is a, and 3, which is c, all over 2 times 1. Okay, well, inside here, 2 squared is 4, minus 4 times 1 is 1, times 3 is 12. Okay, square root of 4 minus 12 is negative 8. Right, and right now we can stop. We can stop this problem because our quadratic formula will not help us, because the square root of negative 8 is a non-real number. Okay, and what that means is when we get to the part where we need to take the square root of a negative number, that means our quadratic formula can't help us. There are no x-intercepts. Okay, and that's fine. What we can do is use some other things that we know about our equations in standard form. So I'll erase this. Quadratic formulas no help. Alright. So we'll move on to the axis of symmetry. That should be pretty easy. Okay, in standard form, our axis of symmetry is negative b over 2a. Okay. Our b is positive 2, so we'll have negative 2 over 2 times 1, which is negative 2 over 2, which is negative 1. Right now, we know that our axis of symmetry will be at negative 1. Okay. Okay. So with that information, we can go find the vertex. Basically plotting our x value for the axis of symmetry. We know that our vertex will lie on this line somewhere. So we'll do f of negative 1. That'll be negative 1 squared plus 2 times negative 1 plus 3, which is 1 minus 2 plus 3. We're going to get negative 1 plus 3, which is positive 2. Okay, what did we find? We found a point of our vertex which is at negative 1, 2. Okay, so that point would be right here, negative 1, 2. So our vertex, okay, anytime we plot anything on our graph, on a test or quiz, you want to write it down. That way, again, it shows me that you really know what you're doing. You're not just plotting points randomly. Okay, a couple other things we can do is we can now go ahead and find the y-intercept. which in standard form is very easy to do. It's the value of c, and in that case it's 3. So again, if you wanted to prove that, you could take f of 0. Okay, remember our y-intercept is where x is 0. 0 squared plus 2 times 0 plus 3 is just 0 plus 3. Okay, f of 0 brings a y value of 3. Okay, now again, we use what we know about the axis of symmetry to plot yet another point. Okay, 3 is exactly 1 unit. Okay, is exactly 1 unit away from the axis of symmetry. So we know that there should be another point to the left of the axis of symmetry that is 1 unit away on that same horizontal line of y equals 3. So that would be right here of -2, 3. Okay, so what we can do is try finding another point. Okay, I like to stick to positive numbers. So I'll plot the point where x is equal to 1. So in this case, we'll get f of 1 is equal to 1 squared plus 2 times 1 plus 3. We're going to have 1 plus 2 plus 3, which is going to be 6. F of 1 is equal to 6. So we found the point 1, 6, which is right here. And again, now that's 2 units away from the axis of symmetry, so we can go 2 units to the left of the axis of symmetry to find that point. So here's what we got. We got the vertex, axis of symmetry. We've got 4 other points. That's all you'll ever be asked to do on a test or quiz in terms of graphing a quadratic. Vertex, axis of symmetry, 4 other points, and you're good. All right. Thanks for tuning in. We're done.